All right, today we're going to talk a little bit about transformations of functions. To begin with, I want to talk about three common functions whose picture I'd like you to know. The first common function is simply a line. And how do we graph a line? Well, one way is to put it in what? Slope-intercept form. Y is equal to mx plus b. That allows us to find the slope, which is m, and the y-intercept, which is b. So an example might be if y is equal to 3x minus 2, that's a line that has slope 3, and y-intercept 0 minus 2. So I go 0 minus 2. Then I go a slope of 3, which means up 1, 2, 3, to the right 1. That gives me the point 1, comma 1. And once I have 2 points, I can draw that line. The next simplest equation, whose picture I'd like you to know, is y is equal to x squared. Now this curve is called a parabola. The smallest y value for y is equal to x squared, if you think about it, is 0, since you're squaring. And that occurs when x is 0, and that corresponds to this point down here. There are some other points we can plug in. When x is 1, y is 1 squared, so there's 1. When x is minus 1, y is minus 1 squared. That gives me a value of 1 as well. When x is 2, y is 2 squared. That gives me a value of 4, and you keep on going. I plot a few of these points. I draw a smooth curve, and that's how I get this picture of a parabola. You'll notice something about this parabola. In particular, it is symmetric with respect to the y-axis. What do I mean? I mean, if you take this part of the curve and you reflect it about the y-axis, you get the second part of the curve. So the right half is a mirror reflection of the left half. Right? Intuitively, this piece reflected gives me this piece, and that's the entire curve. So we can talk about symmetric with respect to the y-axis, and in fact, this equation, y equal x squared, is. All right, the last curve that we need to keep in our back pocket is a cubic. Y is of degree, or x is of degree 3. It's the curve y is equal to x cubed. If I plug in a few points, I'm going to get 0, 0. When x is 1, y is 1 cubed. That's 1. When x is minus 1, y is minus 1 cubed. And if you think about it, that has a value of minus 1. When x is 2, y is 2 cubed. That has a value of 8. When x is minus 2, y is minus 2 cubed. That has a value of minus 8. And I put some of those points on the graph. And that's how I get this smooth little curve that looks something like that. And that's what y equals x cubed looks like. Now, if you'll notice, every point I have up here, I have this corresponding point down here across the origin. Same distance away. If I have the point 2,8, if I go through the origin, same distance, I have this other point -2, -8. That kind of symmetry we call symmetric with respect to the origin. Get it? Now, what does symmetric with respect to the origin mean? Well, essentially it means that if you take the right-hand part of the curve, and if you reflect it twice, once across the y-axis, and then again across the x-axis, that where you end up is the other piece of the curve. So the curve looks like that. So what am I saying? That y equals x cubed, which looks like that, is symmetric with respect to the origin. And symmetries oftentimes are very useful in trying to graph things. Well, we're going to stop there.